everyone. Today we are going to discuss very important point, that is difference between Newton's law of gravitation and Coulomb's law. This Coulomb's law is also called as electrostatic force. Welcome to my academy, the Academy for Basic and Applied Physics. So here Newton's law of gravitation is also called as gravitational force. So we are familiar with that, the force which is directly proportional to the product of their masses m1 and m2 and inversely proportional to the square of distance between them. So we can say that F is, which is the force which is directly proportional to the product of their masses m1 m2, and F which is inversely proportional to the square of distance between them. So F is equal to, this is the proportionality constant, and that is called as the universal gravitational constant m1 m2 upon r square, because m1 m2 is directly proportional and r square is inversely proportional. Z is universally gravitational constant, G having the value 6.67 into 10 to the power minus 11 Newton meter square per kg square. If we have considered the mass m1 and m2, m1 is equal to m2 is equal to 1, and distance between them is 1 meter. At that time we can say that all this m1 m2 and r are 1, so that's why F is equal to G. So we will get the F is equal to G if we have considered the m1 m2 is equal to 1 and r is equal to 1. So gravitation means the force of attraction between any two bodies in the universe. तो यूनिवर्स में जो टू बॉडी में जो अट्रैक्शन रहेगा हम उसको ग्रेविटेशन बोलते हैं. So in Coulomb's law, that is called as electrostatic force, we know that there are two types of charges. We are familiar with that. There are two types of charges. One is the positive charge and another is negative charge. So here we are familiar with that, if the body consists the mass, and mass may having the charge or that is neutral. So for example, neutron, we have considered the neutron is neutral, but neutron having the mass. But suppose we have considered the proton, neutron, electron, they having the mass as well as charge, and due to that they have possesses the mass as well as charge. So we can easily calculate, due to according to the gravitational force, we can calculate the gravitational force, and due to the charge we can calculate the electrostatic force or Coulomb force. So due to the charge we will calculate the electrostatic force or Coulomb force, and due to the mass we can also calculate the gravitational force. So here according to the Coulomb's law, suppose we have considered the 2-point charges, and here we have considered the 2-point masses. So here the force which is directly proportional to the product of their masses q1 q2, and the distance between them is r, so that is inversely proportional to the square of distance between them. So F which is directly proportional to the q1 q2, and F which is inversely proportional to the r square. So F is equal to, we can write, this is the 1 upon 4 pi epsilon 0, this is the proportionality constant, this epsilon 0 is the free space permittivity, or also called as permittivity of free space. Here q1 q2 are the two charges and r is the distance between them, so that is the q1 q2 upon r square. So this permittivity of free space which having the value 8.85 into 10 to the power minus 12 Coulomb square per Newton meter square. So this suppose we have put this epsilon 0, that is the permittivity of free space value, this 4 multiplied by pi, 1 upon 4 multiplied by pi into epsilon 0, so we will get 9 into 10 to the power 9. So this proportionality constant which having the value 9 into 10 to the power 9, and here suppose this is the proportionality constant in gravitational force which having the value 6.67 into 10 to the power minus 11, and this is the 9 into 10 to the power 9. So here proportionality constant, this having the very large value as compared to this. So now we are going to discuss the important points of Newton's law of gravitation and importance point of Coulomb's law or electrostatic force. So gravitational force is always attractive. So here what will happen? So gravitational force is always attractive. There is no repulsive force in gravitational force because we have considered the mass, which is directly proportional to the product of their masses and inversely proportional to the square of distance between them. So here what will happen in electrostatic force or Coulomb force, charges are two types, positive or negative. Due to the, suppose we have considered the one charge is positive, this is the plus q1 charge, positive charge, and here we have considered the another minus q2 charge. So due to the opposite charges, so we are familiar with that the unlike charge attracted to each other, so we can say that there is the attractive force. So the magnitude of force is 1 upon 4 pi epsilon 0 q1 q2 upon r square. And here suppose we have considered the one charge is plus q1, another charge is also plus q2, both charges are like charge, so there is the repulsion between like charges. Similarly, we have considered the minus q1 charge and another minus q2 charge, so there is the repulsion between like charges and there is the attraction between unlike charges. So like charge repel to each other, so that's why here came the minus sign. Here is the positive sign because due to the unlike charge attracted and like charge repel, that's why here is the negative sign, that is 1 upon 4 pi epsilon 0 q1 q2 upon r square. So there is the repulsive force between the like charges and attractive force among the unlike charges. So here the gravitational force is central force. Similarly, the electrostatic force or Coulomb force also the central force. So what is meant by central force? Suppose we have considered the particle and the center, from the center we have measuring the distance, so we can say that that is the central, which start from center, that's why it is called as central force. Similarly, for these two charges, they start from center, so distance is considered from center of that charge, so that is the central force. That is inverse square law, that is 1 upon r square. We are familiar with that, that is the inverse square law. Both this electrostatic force as well as gravitational force are the inverse square law. So why it is called as inverse square law? Because which is inversely proportional to the square of distance between them, and due to this square of distance between them, so if the distance between particle is double, suppose here we have considered the r is equal to suppose 1 meter, and next case suppose we have considered the r is equal to 2 meter, so we have increasing the distance by double. So if the distance between particle is double, then the force we have calculated, that force is decreases by 1/4. So why that which decreases? Suppose we have considered this g m1 m2 are constant, and just we are double the distance between two particles, so due to this, that is the r square, and that's why it is force which is decreases by 1/4. Similarly for this also, here the gravitational force, which is the proportionality constant, is z m1 m2 upon r square, and here is the Coulomb force, that is 1 upon 4 pi epsilon 0 q1 q2 upon r square. So here g having the value 6.67 into 10 to the power minus 11 Newton meter square per kg square, and this 1 upon 4 pi epsilon 0 is equal to 9 into 10 to the power 9. So as compared to this value, this 6.67 into 10 to the power minus 11 and this 9 into 10 to the power 9, so this proportionality constant in gravitational force as well as in Coulomb force, the value of z is extremely small. So the value of z is extremely small as compared to the 1 upon 4 pi epsilon 0 value, that is 9 into 10 to the power 9. That's why in our daily life we do not experience the gravitational force. So due to this small value in our daily life, we do not experience the gravitational force. So here we can say that the Fg is very weak than the Coulombic force. So we do not experience the gravitational force. The value of Z is not depends on size, nature and medium between two bodies. So gravitational constant is constant. It is no matter what medium in between them, what are the size of bodies, what are the mass of bodies, what are the nature. So that is independent of nature, size and medium between them. But in Coulomb force, it is depends on medium. So Coulomb force is depends on medium. If these two charges we have put in vacuum or free space, so here this formula for the charge we have put in free space, 1 upon 4 pi epsilon 0. This epsilon 0 is the permittivity of free space, that is q1 q2 upon r square. Suppose these two charges we have put on material medium for wood or insulating medium. So at that time what will happen, here came the additional quantity, that is the K, that is called as the dielectric constant, so epsilon 0 multiplied by K, that is in denominator, so we can say that whatever the force we have observed, suppose we have took the two q1 q2 charges are same quantity, distance also we have considered the same, and that two charges we have put in vacuum or in air. For air the K is equal to approximately 1. So in air or in vacuum we will get the Coulombic force, but that two charges which have the same magnitude that we have put in material medium on a wood, suppose we have considered, with same distance. So due to the wood having the dielectric constant or insulating material, suppose we have put on insulating material, so that plastic material which having the dielectric constant, and that dielectric constant is divided by denominator. So that's why the force between two charges in air or vacuum, we will get the large force value as compared to the material medium. So it is the force, Coulombic force is depends on medium, magnitude of charges and distance between two charged bodies. So gravitational force of attraction between two bodies is not affected by nearby present other bodies. So here what will happen, suppose we have considered the, according to superposition theorem, suppose we have considered the mass m1, m2 and m3. So here we want to calculate the how much the force on m1 body due to the m2 and m3. So presence of another charged body nearby to that body, that is not affected by the force according to superposition theorem. So for example, suppose here we want to calculate the force F1 between m1 and m2. So F1 is equal to G m1 m2 divided by r1 square. Similarly, we want to calculate the force among these two, m1 and m3, which have the distance r2. So F2 is equal to G m1 m3 r2 square. So resultant force is F1 F2, that is F is equal to that common we have taken gravitational constant G, and inside the bracket m1 m2 divided by r1 square plus m1 m3 r2 square. So here we can say that due to the presence of nearby other bodies, that is not affected by the, while we have calculating the force. Similarly, for the electrostatic force or that is Coulomb force of so electrostatic force of attraction or repulsion between two charged bodies is not affected by nearby present other charged bodies. Similarly, here we have considered in this way. So here there is the proportionality constant 1 upon 4 pi epsilon 0, that q1 q2. So force between q1 q2 divided by the distance r1 square. Similarly, this is the f2, and q1 q3, this is the q1 q3 r2 square. So resultant force F is equal to F1 plus F2. This is the F2 and this is our F1. So we will get F is equal to this proportionality constant. We have taken the outside of the bracket 1 upon 4 pi epsilon 0, inside the bracket q1 q2 upon r1 square plus q1 q3 divided by r2 square. So this gravitational force which having the infinite range, no range, so which having the infinite range. But for the Coulombic force, which is start from wide range from 10 to the power minus 13 meter to many kilometers. So below 10 to the power minus 13 meter, there is the predominant of nuclear forces. So beyond the nuclear size, we will measure the, that is, Coulombic forces. It is based on speculative observation. So this gravitational force is observed on the speculative observation, but the Coulomb force, it is based on experimental observation. It is based on experimental observation. If you like this lesson, please like, comments, subscribe. Thank you for watching this video till to end.